Alright, let's get started with problem number 4. This will demonstrate a couple of the simple harmonic motion concepts that you'll see in the other problems. So, we start off with a mass of so this is just an object undergoing simple harmonic motion. It doesn't say whether it's a pendulum or what. It's just, oscillating back and forth. Whatever it is, it has a mass of 0.12 kilograms. It has an amplitude, which we're going to label as x sub m. Amplitude of 8.5 centimeters, which we have to convert to meters, 0.085 meters. It also has a period, which we'll label as t, of 0.2 seconds. So part A, we're looking for the magnitude of the maximum force. We can use Newton's second law sort of as the net force, but in order to do that we need the acceleration. And so we're just going to use straight up the definition of simple harmonic motion, which right here, the definition, A max anyway, for the maximum force, so this guy right here. And if you remember, what was cool about simple harmonic motion is that the maximum acceleration equals the amplitude, but multiplied by a factor of negative omega squared, negative angular frequency squared, and that comes from the second derivative of the x function. And so what does this equal? Well, omega, don't forget, is 2 pi over the period. It's the inverse. Frequency and period are the inverse of each other. And so let's just stick that up there. So we get negative 2 pi squared is 4 pi squared over t squared xm. And we know everything in here. Negative 4 pi squared time over 0.2 squared times 0.085, and so that equals 83.89 meters per second squared. Piece of cake. And part B, we'll use the fact that omega equals the square root of k over m to find the spring constant k, which is right here. So square both sides, omega squared equals k over m. Multiply m on both sides, m, bye bye. So k equals m omega squared. We know the mass is 0.12, and we know the omega is basically this guy again up here, 2 pi squared over t squared. So we'll just call it 4 pi squared over 0.2 squared, and that equals 118.4 newtons per meter. So not too shabby. These first problems should be pretty quick. The next is probably going to be just a couple minutes. Maybe I can even do it in under a minute. All right, bye bye.